Hello everybody, my name is Dylan Mulkey and today I'm going to be going over my chemical compound I picked this term called Draculin. Now Draculin, as you may have guessed, is inspired by Count Dracula, a famous vampire in literature, and this is because Draculin is a protein, a glycoprotein more specifically, found within bat saliva that works as a blood thinner. And what this does is, as it says, it prevents the blood from clotting up within the body. And this means that when the blood doesn't clot up, it stays flowing in a liquid state. This makes it easier for the vampire bat to drink from and eat without having to worry about it trying to scab over essentially or stop the blood from coming out. This was first identified in 1998 by a group of researchers studying the bat saliva and its potential medical properties. After all, it contains 144 amino acids. Currently, there is a synthetic version called DSPA, or desmodiplase, being developed. There is not much research about it, but in consideration that this was first discovered in 1998, it is a fairly new, in my opinion, compound being discovered. It's going to take a while. So moving on, how does Draculin work? So Draculin works by inhibiting the factors IXA and XA. These are both factors that are used to start the blood clotting process, and it essentially stops that from happening. But you see, there are current drugs that do that, such as warfarin and heparin. They are used as blood thinners not over the counter, pharmaceutical purposes and medicinal. So you need a prescription for this, and it works to thin out the blood in the whole system. But Draculin only works to impact bite site areas, which means that if a bat bites your ankle, you are only going to bite at the spot where the bat bit you. You're not going to deal with what warfarin had you do, where you just, if you get a cut on, both your hands, they're both going to bleed a lot. It's not going to do that. It's just going to do where you were bit. This happens in two phases to impact blood clots from becoming clotty. And essentially, the bite site zone is only temporarily stops clotting. It's not permanent, doesn't have more lasting effects like warfarin will have. Moving on, as mentioned, Draculin is very interesting for scientists and a lot of people in the medical field because of its potential medical applications. As you see on the site here, we have warfarin and heparin. These are both the current medical things that we have for blood thinners. There aren't a lot out there. These are the most popular ones currently. And Draculin has a lot of potential good purposes, especially for stroke treatment, PVD, and pulmonary embolism. And this is because it could be a safer way to attack blood clots or prevent blood clots without having to deal with impacting the whole circulatory system. It would just impact the site that they want to impact. This is also a good point for surgery in cardiovascular use, since surgeries, if you aren't able to impact one site instead of impacting the whole body, it could make it a whole lot easier, especially for heart surgeries. And the synthetic version of Draculin could also offer an extended blood clot reduction, meaning that a patient wouldn't need to continuously take doses of heparin or warfarin if they could have Draculin. Moving on, some of the challenges that come with Draculin, though, is the fact that it is found in bat saliva. It is not something that you can just easily make, and this is because it's a complex glycoprotein structure that needs to remain biologically active. This is what makes it so hard, is that scientists are struggling to find a way to make it shelf stable while also ensuring that it remains active. That way it can do its job of blood thinning, essentially. And this also raises ethical concerns that because it comes from bats, it raises concerns about animal welfare issues, such as how they're going to be treated in labs for people researching this topic, and how are the populations going to be protected, since bats have a very bad reputation in life. They're connected with horror folklore. They're considered dirty, diseased, scary, when all they are is they're just little guys who are hungry. Let's be honest, we're all little guys who are hungry every now and again. So yeah, they're currently working on a synthetic version of the DSPA. That way they don't have to rely on bats forever, just to help get a little stepping stone where they want to be. In conclusion, Draculin has a lot of potential for being specifically a blood thinner, which is what makes it so interesting. There is more research that needs to be done. It isn't a topic that is very well talked about. There's a lot of information. When you look up Draculin, you get photos of Count Dracula all over Google. No joke, I went through so much stuff about Count Dracula to find stuff about the bats. It's so funny. but it has a lot of good future applications that could be used in so many different ways to help future patients and current patients. We just have to get there. In order to do that, we just need to get the right stepping stones to prevent blood clots and revolutionize stroke treatment, blood clot treatment, reduce side effects, and improve patient outcomes overall. It's all thanks to the little bat. Look at him run. They're so funny. They're so cool. I like them a lot. Thank you for watching.